Welcome to the third video in the series on how to use the Machine Language Manager. This one is going to show you some example programs. The Machine Language Manager is a 2K cartridge for the Bally Arcade, also known as the Astrocade. And in this picture here, you can see it was an expandable computer system. The Machine Language Manager, as I've mentioned in previous videos, is a machine language monitor cartridge. It basically allows you to program the Astrocade using opcodes. It does not require you to have extra memory. It will allow you to take advantage of extra memory if you have it, like if you have the little white RAM that Ken Lill and Michael White designed a few years ago. You can also use like the Viper expansion and the Blue RAM expansion, which it can give you up to 32K depending on which RAM expansion you have. This video is going to be dealing with 4 programs that are included as examples in the Machine Language Manager manual. There is actually going to be 5 examples total, but the 4 from the manual are Critter, the standard color generator, a 256 color program. It allows you to see that many colors on the screen at once. That's the entire palette of the Astrocade, and an ASCII character set program. The last one is going to be a program that was released on tape, and it's called the Goldfish demo. All of these programs are archived on ballyarcade.com and can be downloaded using this 300 baud interface. The 4 programs in the Machine Language Manager manual are actually short enough that if you want, you can type them in yourself and not even load them. The Goldfish demo, while you could type it in yourself, it is quite long and you'll probably want to load that one from tape. Enjoy the examples. The first program that I'm going to demonstrate is called Critter by Brett Bilbrey. This program is only about 90 bytes long, but it shows how you can move a character around in Bally Basic using machine language subroutines that are contained in the Astrocade's system ROM. Before this program was published, the only way to actually get graphics on the screen was a little bit difficult on the... I take that back, it wasn't difficult, but you couldn't get graphics on the screen that were easy to move around quickly. This program allows users to move the objects around the screen graphics. In this case, it looks like a little maybe Space Invaders creature. You can move it around with ease, and in this program you can control the speed of the critter using hand control number 1. You can have it moving very, very, very quickly, or not at all. You can make it still. This program first appeared in the October 1980 issue of Cursor on pages 66 through 67. It was also mentioned in the editorial about the Peek and Poke manual on the first page, page 65 of the Cursor newsletter. In this basic version of the Critter program, you can see the listing takes up a good maybe 65 lines of code or something like that, and it would take a while to type in, but like I was saying earlier, the machine language portion of the code is actually only around 90 bytes. I think it's 93 bytes total, and it uses several of the routines built into the system. You would never know that by looking at this basic program unless you understand machine language already, and you would have to convert from this odd way that Bally Basic and Astro Basic store hexadecimal data. You can see some of the hexadecimal data can take up to, 6 bytes. Like, for instance, in line 130, you have negative 20,275, but that's only going to end up being a 2-digit hexadecimal number, and it's going to store just 1 byte in machine language in RAM. I'm not going to go into detail about how this program works. You can actually read about that in the Peek and Poke manual, or you can look at the source code to understand it. I just want to show you what the program looks like. This is the source code for Critter. This is on page 7-2 and 7-3 of the appendix of the Machine Language Manager manual. This program was also published in the Arcadian in the December 1980 issue, so it actually was a follow-up to the Cursor newsletter publication, but not as much information was published about it. Brett does credit Tom Wood, Dave Ibach, and John Perkins with helping him write this program. He said without them, he would not have been able to write the program at all, or maybe not as easily. In this program, you actually control the speed of the critter moving around the screen. In the basic version of the program, you could actually halt the program and the critter would still continue moving around the screen. This is known as background, foreground processing. Not too many programs took advantage of it because you did have to write your code in machine language, plus there wasn't really a lot of RAM to store your program in. Looking at this program now, I just want to give it some background for those who are interested in knowing about what routines it does use from the nutting manual. It uses the vector right routine, the vector routine, the vector right routine, and these are routines that keep track of data that you point it to move your data around, quote, automatically, using information you pass along to the routines. There's byte patterns here. The byte patterns show what the critter would look like. There's also a vector block. This is a part of RAM that the vector subroutines look at to see how they should move about parts of memory. And those parts of memory are screen RAM, and that's how the critter in this case gets moved around. It's also how most probably, of all the graphics get moved around on the Astrocade game cartridges. Here is how critter loads, and this is what the program looks like when it runs. There's no sound here, but there wouldn't have been any sound while you were using the program on real hardware either. And that's the case with all of these programs that I'm showing. There is no sound in them. There could have been, but it just wasn't used. I guess to keep the programs a little simpler so they'd be easier to understand. Now the program will load, and then it will run, and I control the critter using hand controller number 1. You'll notice I made it go very quickly and come to a complete stop. The second program is called the standard color generator. It's a machine language program that displays 4 colors on each side of the horizontal color boundary, so you get a total of 8 colors. The program was written so that you would be able to adjust your TV to look more accurate and represent colors better. I am using the FrameMeister in order to capture this, and I had to kind of compromise, and most people might not notice, but the program colors that I've run and anytime I've ever recorded with FrameMeister are always a little bit off. And that's because in order to make them the correct color at all, I have to get the tint a little bit off. So some blues sometimes look green and some purples look blues. That's just the way it is. And this color bar generator, which is written specifically to spot that kind of stuff, does a good job of showing it here. Color bar generator was published first in the May-June 1981 issue of the Basic Express newsletter. It was actually a supplement to a program called the Run Maker, which was a basic program that allowed you to make a self-running program in machine code. So as an example of this, so you'd type in the basic code for Run Maker, run it, and then you could type in opcodes that would save to tape. And the program he uses, standard color generator. He would later republish this program in the Machine Language Manager manual on page 7-4. This program makes use of a few system subroutines. Notably, they are int_pc, callset, and rectangle. int_pc allows you to call more than one subroutine at a time, which saves a few bytes here and there. Callset allows you to point to a table, which will automatically set the color registers. And finally, rectangle allows you to draw a rectangle, which is how he draws the bars on the screen. I'm going to talk more about the colors used as the program is running. So watch the program load, and then watch it run, and I will take it up from there. Now that the program is loaded, the colors are set by the program to be from left to right, black bar, a white one, yellow, and green, and then a blue, a magenta, a red, and cyan. Looking at the screen here, you can see they're pretty much right. If this is looked at on a CRT screen, they look much closer to the colors that they should be. But they don't look too bad here, and it's a good way to adjust the FrameMeister and a CRT screen to get the colors about as correct as you can get them. One of the first programs that I ever typed into Bally Basic is from this Astro Basic manual. This is for Bally Basic that has the built-in 2000 baud interface. This basic is usually called Astro Basic. And here on page 94 is the actual program listing. It looks pretty long, but the program itself, if it's written in machine language, which is why the machine language manager is so cool, is rather short, but it looks really long if you're typing it in BASIC. I'm going to read you the description here because this got me to type in the program in, I'd say 1994, 1995 when I was first discovering the Astrocade. And I saved this to my computer even back then as a WAV file. The description says, "This program has especially delighted the average user as it appears to be impossible to accomplish such a thing in Bally Basic. You will find out how good your television is as this program will push its color displaying capabilities to the limit. Thanks to the Basic Express newsletter for sharing this program with us." When I first typed in this program about, I guess it was 25 years ago now? Wow. When I first typed this program in, I was pretty impressed by what it could do, and I was also impressed by the input that the user could have into the program. If you turn the knob on hand control number 1 back and forth, you can control how many colors are displayed at one time, which is pretty neat. As the description of the program alludes to, this program first appeared in Cursor. And Cursor is the name of the newsletter that went on to become the Basic Express for its last 3 issues. It appeared in the January-February 1981 issue of the newsletter. And here is the program's description on page 86, the first beginning listing of the program, and then the second page of the program. What is shown here on this page 87 is the actual machine language listing, which is not shown in the basic manual, and probably would have been useful. It only would have taken up one extra page. It might have confused some people, but it also would have definitely have helped them understand a little bit about what's going on in the background, because the basic manual describes this program as a basic program when it is not a basic program at all. The basic portion is a basic loader, which takes, using basically pokes, and pokes the program into memory and then runs it. But the program itself is not written in basic, and that's why it's able to show 256 colors on the screen at one time. Something that confused me about the original listing in the Astro Basic manual, and also as it's listed here, is that it says, "This program will give your TV its supreme test of quality. We use a 10-inch Panasonic with our Bally in the office, and it is capable of only showing about 14 colors. Our Zenith, however, showed them all." What is it talking about here? I mean, NTSC can show all 256 colors easily. In fact, the Astrocade was designed with NTSC in mind and is considered to be a system that can give very accurate NTSC colors. Unfortunately, the system was never designed for PAL input, which would be used overseas, or PAL output, I guess. So here's the program. Now this program in particular, out of all the programs I recorded, shows up kind of poorly when captured with the FrameMeister. The colors blend much better on a CRT screen, and that has to do, I think, just with the way CRT screens are a little bit blurry to begin with. And so my setup to record here is it goes RF into a composite demodulator, takes the RF, puts it into separate video and audio, puts that into my FrameMeister, and then goes into my capture card. And by the time all that processing is done, the program or the picture doesn't look super clear, but you still get an example of what's going on. When the paddle is moved all the way to the right, I believe you can show the colors, all 256 colors from the top to the bottom, and you see most colors. When it's all the way to the left, I think, I can't remember because I haven't used the program in a few weeks since I recorded this segment, then you just get no additional colors on the right side of the screen. But check this program out, and if even if you don't have the machine language manager, try it out sometime on your real hardware if you have it. It's simple to load in through Astro Basic, and it's a neat program to look at, especially if you've only seen basic programs running in like 2 colors. You might be a little surprised by what the Astrocade is capable of, because even most cartridge programs didn't use this many colors at once. I think the only cartridge that used most colors is Treasure Cove. Here is the 256 color program as it was printed in the Machine Language Manager manual. If you do a comparison of how long the program is, the program for the MLM is 46 bytes. The program, as it must be written to work under the Bally Basic, is 62 bytes. And there are several reasons for this. I'm not going to go into them, but let it just be said that Bally Basic requires more overhead. You have to save registers and then return them to their proper place in RAM. Otherwise, Bally Basic goes off to Never Never Land and your program's going to crash. And this is if you run any machine language programs in Bally Basic. This isn't required in the Machine Language Manager, which is optimized to be easier to write machine language programs in. And maybe by now, especially with a program like this, where you get a comparison of the basic listing and the actual opcodes, remember you only have to type in 46 bytes for this program to work in the MLM, but it's much, much longer in BASIC. The program itself in RAM doesn't take as much memory in BASIC, but just the machine language portion of the loader for BASIC requires much more typing and thus more RAM in itself just to get it into RAM and run the program. So this is a good reason you'd want to use the Machine Language Manager. Here's the program running, and remember, like I said, you have the power to control how much of the 256 colors are on the screen at one time, which I like. The last program that is printed with its own source listing in the Machine Language Manager manual is a program that prints out the printable characters in ASCII on the Bally system. However, the Bally system doesn't use standard ASCII, which was pretty typical of the time period. ASCII was invented in 1963. Well, it was first published as a standard in 1963. When I say standard, it went through all sorts of different uses through computers over the years. So there's standard ASCII, which is normally nowadays called US ASCII, and then there was there was PET ASCII that was used on the Commodore machines. There was Atari ASCII, which was used on the Atari machines, and they basically, just like the Astrocade version of ASCII, also for not all of the ASCII codes were the same. So, like for instance, if you're looking at this table here, which is the character code table, they don't even pretend to call it ASCII, but it shares a lot of similarities between ASCII. If you look at in decimal code 105, if you print out code 105, you'll get clear printed to the screen, and that's how the keywords are printed in BASIC. And it's handy because it saves bytes. A quick aside, just to show you how far back this original code goes, we would have to go back to the Bodic code, later refined a little bit in the 1870s. Yes, the 1870s for telegraph transmission. This was a 32 character code, so it was a 5-bit code. ASCII is not an 8-bit code, even though sometimes people think that. It's actually a 7-bit code, which is why it can only have 128 characters in it. And as we can see here, the characters are going to be 0 through 127. If you compared this character code table for the Bally against an ASCII code, there'd be quite a few differences, but there are similarities between decimal 32 and decimal 90, which I think they overlap 100%. And that's what we're going to print in this program. We're going to print that onto the screen in the small character font. One other aside here is there's also another code that is still used in the IBM mainframe world called ASCII, and most people don't know how to say it, but it's spelled EBCDIC, and I used it on an ES9000 in the mid-90s, which is a System 360 mainframe. It was pretty interesting. Most hackers hate it because it's so inexplicable, I guess you might say. ASCII is pretty easy to understand, and ASCII is too. It's just different and people aren't used to it. After I ran this program in machine language, I thought it would be appropriate to run this program in BASIC. So I wrote a short version. So at first it would compare the font size because BASIC's font is so much larger. But it's just a one-line program, and it shows also what BASIC is capable of doing in a short program. And a Z80 version of this program is also short. They're obviously very different. They're two different languages. But here's the basic program for all it's worth. And it's going to show the exact same codes. As you can see here, 32 through 90 is in my for loop for BASIC. And when I print out those codes to the screen in the Bally character set, we get like the special characters, the numbers 0 through 9, and the letters A through Z. Here is the ASCII character set program as printed in the MLM manual. This one actually has a word of explanation, which I think is interesting because the other ones really don't. I mean, they have comments next to each program line, but they don't really have there's 2 paragraphs of explanation here. I'm not sure why he thought it was necessary. Maybe because there's a mnemonic called DGNZ used, which is maybe a little confusing to beginners, and I guess it might have been. I don't remember if I was confused by it or not. But so he explains how the program works. But essentially, this program is going to do the same thing that the basic version of the program does. Something this program lacks and doesn't use at all are any calls to the built-in routines in the Astrocade. This one does call a built-in routine that's part of the machine language manager, but that's all. So here's this, and after this there's only one program left to look at, and that's going to be the Goldfish demo, which actually is not printed in the machine language manager and was available separately. This is the last example program that's going to be used in this video. This is called the Goldfish demo, and it was first mentioned in the Arcadian in the April 1982 issue. Here's what the Arcadian had to say. Goldfish is a program that was developed by Andy Guevara by the use of his machine language monitor program. He displayed it to us at the fair, and it is a cute demonstration piece. A fish tank appears, a number of fish swim back and forth, continuous motion, no jerks, and a little pussycat looks longingly. A clock is included, and every minute the cat meows. Andy has a listing for $3 and a tape that can be loaded into either BASIC or Machine Language Manager cartridge at $5. Check the address in their full-page ad in this issue. Something I find interesting here is that Bob Fabris, the editor of the Arcadian, is referencing, quote, the fair. And what he's talking about is the West Coast Computer Fair. And that was held just a couple of weeks before this April 1982 issue. The fair, the West Coast Computer Fair in 1982 was held March 19th through the 21st in San Francisco. And it was kind of a ritual for the folks from the Arcadian and other Astrocade fans to get a booth together, and they would then see what's going on. I think in this year in particular, they were talking about the Z-Grass keyboard. And also mentioned on this very page, page 57 of the April issue, is videocades at closeout prices. The videocades he's talking about are cartridges. That's what Bally referred to their cartridges as videocades. People don't really do that nowadays, but it seemed back at the time period most people did. Bob says, and this is just a side note here, that the videocades that are left over from the West Coast Computer Fair are available, And since he doesn't want to go into the mail order business, you can get Galactic Invasion, Bally Pin, Space Fortress, and Astro Battle for $26 each, and the new version of Basic for $46. And you can get a deal on the old version of Basic for $21. I think that's pretty cool. It's not going to be too long, maybe within a year, that some of these cartridges are going up for closeout prices at Montgomery Wards and stuff like that. During the American video game crash, for $2, I've heard stories of people picking up whole boxes of these games for under $10 during that time period up until like 84 or something like that. And there were even Astrocades that were available brand new in the box for $25. Yeah, things have changed, right? Here's the full page ad that Bob is referring to, but this is in the May 1982 issue. This is the ad for the Bit Fiddlers demo. It's on page 74. I'm not going to talk too much about this page here, but here's the demo in close-up. I'd first heard of this demo from this ad, and it took us quite a while to come across the actual listing and the tape dump of it so that we can actually try it out. But it always made me curious because it says Goldfish demo. Actually, they're neon tetras, but that would make the name too long. This demo tape is designed to show the power of the Machine Language Manager cartridge. It's a relatively short program, but it independently controls the actions of 7 goldfish, a digital clock, and the meowing of a cat. And it's in 4 colors. Animation is smooth and non-blinking, and Goldfish does not require the MLM to run. The program will run with Bally Basic, the Astrovision Basic, or the MLM. An interesting side note, once loaded and running, Goldfish no longer needs a cartridge in the slot. You can remove it and the program will keep running until you hit reset. Here is a picture of the Goldfish demo as it was released by the Bit Fiddlers. This side is the second side, which is the MLM version of the program. The other side had the Astrocade version of the program in 2000 baud, and also the Bally Basic version of the program in 300 baud basic. This demo here loads the side B, so that you can check it out, and you'll get to watch the program load. The instructions for the Goldfish demo are 2 pages long. Here's what it says. Again, it mentions that these are neon tetras, and it tells you how the program can be loaded into Astro Basic, which it will be loaded using :input or :run into Bally Basic. The Bally Basic version, which is 300 baud, and the MLM version, which is also 300 baud, take different amounts of time to load. The Bally Basic version takes about 4.5 minutes to load, and the MLM version takes about 1 minute and 20 seconds. And the reason for this is because the Bally Basic version has to be poked into memory using the odd method that Bally Basic uses to record bytes, where the MLM uses hexadecimal, so it takes a lot less room in the recording in order to load these programs. The instructions for the Goldfish demo basically tell you to enter the time. They go into detail about how this is done, but it's pretty easy to figure out. After you enter the time, the program starts running. This is the first page of the machine language listing for the Goldfish demo. It's 14 pages total. On this page, you can see in the upper right-hand corner, it says SD Systems Z80 Assembler. And I looked that up, and the SD Systems Z80 Assembler is a assembler that was written for CPM system in, I guess, the late 70s, early 80s. And SD Systems, they did create some hardware, including Z80 computers, but they were very limited releases. Those computers used the S100 bus, which is also sometimes referred to in its original form as the Altair bus, as it was used in the first Altair computer. But SD Systems also created software, and this assembler, it seems as though Andy Guevara used that to write both the MLM cartridge itself and the Goldfish demo. And I can't blame him. Writing this program in opcodes using paper would be, and then hand assembling it would be quite difficult and time consuming. So he was using probably a computer with, I guess, 64K of RAM, a proper keyboard and stuff like that. But he was probably using something that didn't have graphics. So he was able to get his graphics going on a system a little less expensive probably, like the Astrocade, but also capable of having color graphics. On this first page, you can see that the equates are sent here. And this is how he was able to make the program, quote, automatically talk to the Astrocade's system subroutines. Because here, I'm going to give you some examples. He uses words like VWrite and WriteR and string dis to talk to the proper places in RAM for how to call these programs using the system and syssuck subroutines that are built into the Astrocade. I'm not going to show the complete listing here, that isn't required, but I'm going to show 2 more pages. This is the 3rd page of the Machine Language Manager source code, and right at the very top here it says org 4B40. What that means is anything after this is going to assume it's running from that position in RAM, which is exactly where the program is stored in the Machine Language Manager. So he's able to have the assembler take care of all the hard work for him, so he doesn't have to do any hand assembly. And thank goodness for that, because this program is, like I said, 14 pages long. This is the 7th page of the demo, and it's also the last page I'm going to show here. I'm showing it because right around 4D05 in RAM, it's where he starts everything, and the clock is started and stuff like that. He uses the timer in the Astrocade. These are subroutines that all sort of work together in order for movement to be synchronized and times like the clock that is built into the Astrocade to work properly together. I don't really have a lot of experience using the timer myself, but most of the cartridges I actually did use this timer, and the timer is synced, and it is updated every 1/60th of a second. In this way, it reminds me similarly of how the Intellivision's exec works. There's a timer in there, and you're not forced to use it. There's no reason you have to, but it makes programming the Astrocade a little simpler. If someone wanted to go ahead and not use it, they might be able to move graphics around quickly or more quickly than can be done using the Astrocade's built-in subroutines. As I've mentioned already, the program loads in about 1 minute 20 seconds or so. The first part of the load is actually going to show some ASCII text on the screen. It says, "Hold on to your cats. The Bit Fiddlers present the Goldfish demo." It loads in about 20 seconds or something like that, maybe 30 seconds. It loads a portion of the program, and then it loads and executes from there, and it's also like prints onto the screen in large letters, Goldfish demo. It has color cycling, and then the rest of the program loads. The splash screen says it's the Goldfish demo, and after that you can enter time in hours and minutes, and this program actually keeps time in minutes, hours, and seconds. So I actually ran this program in the middle of the afternoon, maybe 2 weeks ago. I just entered the current time, which was 3:46 in the afternoon. So once I entered the current time, the aquarium was drawn on the screen. 7 swimming fish appeared. A cat appears in the background, and he meows immediately when the program starts, and then once every minute. So you'll notice that when the time goes from 3:46 to 3:47, he meows, and then once again on each minute. I actually record 3 minutes of this program running, and then I stop because I think the program's kind of interesting to look at. It's a good graphics demo, and in 1981, it would have held your attention. I guess technically this was released in 1982. It would have held your attention, especially if you're loading into Astro Basic, because it's showing the power that you can do by programming machine language. Programs that were like earlier, like for instance the Critter program that I've already demoed at the beginning of this video, do show how you could use machine language to take advantage of the movement of the subroutines that are in the Astrocade, but they don't show you really how to have extra colors on the screen. Well, this program is completely machine language and doesn't have to care what's happening with Bally Basic. In fact, it does say that you can eject the basic cartridge or the MLM cartridge and the program will continue running. I've tried that with basic. I forgot to try that with the MLM, but it's true. It'll just keep on running. It's unaware that you take the cartridge out. There's a couple other machine language programs written for the Astrocade that are in machine language that run and can be loaded from Bally Basic. Road Toad is another one, and you can just take out the basic cartridge and they'll continue running, completely oblivious that there's no more basic cartridge in there because they're not using the basic cartridge at all. They're using the subroutines that are built into the Astrocade, and they're running from screen RAM, so that's why they don't take up the full screen. Oh, and that's one last thing I should mention is that the aquarium doesn't take up the full screen because the program itself begins right below the aquarium's sand, if you will. The sand at the bottom of the aquarium, I think, is actually made up of part of the program. Very much like in how Yar's Revenge on the 2600 has the program displayed on the screen. The program is going to load now, and you get to sit back and watch the program load, which is interesting in this case because there's extra stuff that you get to see here that isn't available if you watch this program run from cartridge. And if you get a chance to watch this program on real hardware too, it does look a little bit better because, as I've said before, I think in this video and others, These programs were meant to be watched on a CRT screen. Video capture doesn't do them justice. You don't get as much interference on the CRT screen, and so the programs just look better on a CRT. If you have your Astrocade or your other game systems or computers hooked up via S-Video or Composite or something like that, sure, it looks pretty good, and it does look better. But these machines were meant to be shown on TVs with RF modulation. So as much as I can try to show you what these programs look like, in order to really understand them and see them for what they were meant to be, you have to look at them on a CRT TV. Here we go. Enjoy Goldfish demo. Thanks for watching part 3 of the Machine Language Manager series. In this video, I showed you the 5 programs that are MLM example programs. In part 4, I'm going to show you how to use the MLM under the MAME emulator, which can emulate the Astrocade. As of this time, the summer of 2018, the MAME emulator is unable to save programs to tape in either 300 baud format or 2000 baud format, but that doesn't mean you can't use the emulator to run the MLM cartridge. What we'll be doing is I'll be showing you how to make a keypad overlay. I'm not really going to show you how to set up the MAME emulator, but I will show you a little bit about it. For instance, here's the MAME web page. You can download from there. I'll go into all of this more in the next video. From ballyarcade.com, you can download the cartridge images, including the AK-ROM, which is required to run the Astrocade, and you can also download the Machine Language Manager cartridge. Here's an example of the version of MAME that I use running. I'm going to show you just a couple screenshots here, and then I'm going to close out. This is version 0.177 of MAME. This is actually the debug version. This is what I use because whenever I'm running machine language programs that I've written, it's very helpful to be able to debug your programs easily, and MAME allows you to do that. So here it is. You can emulate the Bally home computer, the Bally computer system, and the Bally professional arcade. The Bally professional arcade, its ROM set is called Astrocade, missing the A at the end, and that is the most common Astrocade available. Here we are looking at some of the ROMs that you can use with the emulator. As you can see, it starts off and it's in alphabetical order. Here I have the Machine Language Manager cartridge highlighted. We can start it up and it looks like this. Boom, the Machine Language Manager. However, it's very difficult to type. So if you try to type with the default settings, it's not impossible. I've done it, but it's much better to make your own keypad setup that looks like this. If you have this, you can use any spare system keyboard that you have laying around, and then you would set up the keys to work with it in that way, and you'll be done. I'll show you how to do that in the next video in this series, part 4. See you there.